Hello everyone, I am Vishneshwar Reddy from SRM University AP and my roll number is 1156S, and today I am going to present my project titled Temporal-Aware Retrieval-Augmented Generation for News and Medicine. This project mainly focuses on improving how AI systems retrieve and generate answers from large document database by including temporal or time-based awareness, means a key factor in fast changing domains like news and medicine. And next, coming to first for uh, what is the RAG system? Means retrieval augmented system. What is that? Means it is a framework that combines information retrieval and language generation. In simple words, when we ask a question to the system, first retrieves the most relevant documents from a large knowledge base. Then it uses language models such as GPT or FLAN T5 and to generate a natural language answer based on those documents. And this makes RAG systems much more factual and grounded compared to traditional LLMs that rely only on the training data. And this is all about what is the RAG system. Next, coming to what is the problem with the RAG, means now the normal RAG system and what are the challenges faced. In domains like news and medicine, information changes very frequently. Traditional RAG often rely on old and or like outdated data, which leads to wrong or even harmful answers. For example, outdated medical guidelines or like old government policies. So the main motivation behind this project was to make RAG system time aware, ensuring that the answers are based on the recent and reliable information. Hence, the solution is to add a temporal awareness component. Why temporal reasoning means to explain this, imagine a RAG model answering like for question who is the prime minister of our country recently, or what is the latest COVID-19 guidelines to follow. A normal RAG system might return an old article from 2020 and given an outdated answer. However, real world system must always reflect current and up to date knowledge. Temporal reasoning solves this by considering when a document was published, giving higher importance to the new documents. Like, for example, I will explain in this slide, like example, to make this clearer. Like, imagine we are building an AI-based medical assistant, like questions about AI in COVID-19 diagnosis. The system uses a medical researchers reports and the news articles. If was a normal RAG, it might give outdated answers like the 2020 guidelines for COVID diagnosis. But if we use temporal aware RAG, it understood that news research from 2024 or 2025 means new is more relevant and should be prioritized. The doctor or researchers get the latest medical knowledge, not absolute information. Okay, this is all about temporal. But coming to how actually the RAG works, means retrieval augmented generation system works. Here's how typically RAG workflows operates. Means the user enters a query or question, the system performs data retrieval from large database relevant documents and selected and passed to the generated model, and finally a response is generated. The key challenge here is that retrieval is based only on a semantic similarity, meaning like text meaning, not on time. That's where our temporal enhancements comes in. Like this is all about RAG, how the RAG works. Now, coming to what are the limitations, means what are the limitations of existing RAG. So, the main limitation of existing RAG system is that they only consider semantic similarity, means they do not check when a document was published, in which year, like old data or the new document. For example, if a 2020 paper and a 2025 paper both mention a diagnosis, the system might randomly pick the older one just because of the text similarity. This can cause outdated or even incorrect answers. So we need to integrate temporal ranking to solve this. Like temporal how they now coming to how the data will be stored with the documents. I mean, with the date, the title, how they retrieve like that. In our implementation, each document is stored its metadata such as ID, title, date, and source. The pipeline just injects all raw text files, extracts the data, they extract the dates with time, splits large text into smaller checks, compute embeddings using the sentence transformer model, and finally stores them in FAISS index and .npy files for fast similarity search. I will show it in the uh, uh, project structure while I am showing the code. This combination of document plus metadata allows the system to perform both semantic and time-aware retrieval. Now, how the temporal ranking model will how the temporal ranking is how the documents will rank and how it retrieve means here this slide explains the like temporal ranking model. Here we add a temporal score to each document in addition in the normal semantic score. This final combined score is calculated using this formula like combined score into semantic score plus the time into temporal score plus other something like other weights. So recent documents are more likely to appear at the top of the retrieved list. Technical algorithm uh, this is the main a formula to use it to retrieve the latest documents. Now coming to the algorithm logic used to retrieve. This let's look the algorithm. Like the time score is calculated using exponential decay function. Like time score is equal to exponential of time difference. That means newer documents is high score and older documents large time difference low score. This ensures that the documents get older, their influence decreases automatically over time, helping the system prioritize newer and more relevant data. Now, coming to pipeline output example. Here's an example of how the system performance, COVID, when we ask a question like COVID booster rules, the normal RAG may retrieve 2020 document with outdated vaccination information, but the temporal RAG retrieves the answer using the 2024 policy updates. Now, coming to the applications, main applications are breaking news summarization, retrieving, reporting latest news, medical treatment planning, and financial marketing tracking, and government policy analysis. And coming to the future scope, the system can enhance further by fetching live data from the internet instead of static data sets and adding historical event linking for long-term context understanding. And it also supports multiple languages, so it can handle global data. And now I will show how the project structure and how it works. And after with the execution of the project, this how I will explain clearly. You can see. Uh, This is the project structure, which is temporal RAG, and means this is the first index PY. This code in this file, this script read all the raw text files, extract titles and publish this is title and publication dates and writes them into a JSON file out for processing. It ensures every document carries a time reference, which is crucial for temporal model. And coming to index building pipeline, next this file encodes each document, means it will encode the each document into a vector embedding using the sentence transformer model. These embeddings are stored in a- files, a high-speed similarity search engine, and enabling efficient document retrieval. And this is all about index build.py. And coming to temporal re-rank, re-rank.py file. This is the most important part in the temporal track system in this project. This is here we calculate the semantic here we calculate semantic similarity score and temporal score. Uh, then we combine them using the weighted sum formula. It also applies the combination boost. If newer documents confirm older ones, then older ones get a small credibility boost like that. And coming to the next generate answer file. In this performs the full pipeline, means it retrieves stock documents, constructs a prompt and passes it to a FLAN T5 model for natural language answer generation, and the final output is concise, context-based, and time-aware. And next, coming to the UI bot app streamlight.py, this interface allows us to interactively ask questions, view the retrieved documents, and generated answer. Once we run the command streamlight run, the app opens on localhost, showing both console outputs and the final answer from the local model. Now I will execute. We can see when I execute, it will start running. Now I will enter the question like some questions are there. What AI techniques were popular like this question, and it will take some time to generate answer. It will generate the answer based on the documents which are latest documents and the year mentioned in the question. Based on these all requirements, it will generate the answer. Now the answer will generate it. See what AI techniques were popular in 2021 means it will first give the take the document like 2021 document which I given in the documents, and the last final answer is which is related in the 2021 early model showed promise for detection talks but clinical adoption means this one. This is the answer generated for this question. The latest document is used mentioned in the that. And next, coming to how AI improved cancer diagnosis in recent years. Recent years means we want to get like a 2025 year based on the answer. Let's see what will give the output. See, it will how has AI improved cancer diagnosis in recent years. Now it will take the 2025 document as the latest means here recent years means it will take the 2025 answer. New studies demonstrate consistent improvements in early disease detection. Like will be appeared in the 2025 document. This like this is how the documents are retrieved based on the date we are uploaded and the latest information, and this helps there is no mismatch of information and there is no error means now coming to final, this project is successfully enhanced traditional RAG system by integrating how the temporal awareness, allowing them to generate time sensitive up to date answers, and it also bridges gap between the information retrieval and real time knowledge reasoning, making it particularly like using in the fields like medicine, finance, and news domains. And it also have advantages like improved accuracy and freshness, and its main limitation is that depends on the availability of accurate timestamps, means the timestamps of the document, and can be computationally heavy for large scale data, means for large data it will take so much time, and it is still step forward making a system temporarily intelligent. And this is all about in this video. uh, this is the main advantages of temporal aware RAG system. And thank you for everything. Thank you.